question here is asking us to determine the tension developed in cables AB, AC and AD. In order to do that, the first step, we define our sign convention. So for our sign convention in this case, so sign convention, we take these directions for X to be positive X axis, and this one here for Y to be positive for Y, and we take upwards to be positive for Z. And if we have a moment, then we will take anti-clockwise to be positive, and positive results, that means tension. Negative results means compression. Negative results means compression. So now we defined our sign convention. We will start to represent each one of those forces. I will treat this as my free body diagram in here. I will treat this as a force directed in this directions, and this is another force AC, and that's another vector in there. You just draw this as a free body diagram. So this, I defined a sign convention, I've drawn my free body diagram, so I start to represent each one of those forces in a Cartesian form. So let's start with AB, the force AB. So the force FAB in a Cartesian form, that will equal FB itself, FB. Then the coordinates here on the x-axis for FB will be sine 30. So sine 30 degrees I. For the coordinates on the y direction is going to be, because this one here is it's a right angle triangle, so this is the attached side, which is cos 30, so plus cos 30 degrees J. For F, this is for FAB. For FAC, representing this in a Cartesian form, then we need FC multiplying this. When we look at this one here, FC, it's directly straight on the negative x-axis, doesn't have any y or z components, therefore it's got negative I plus 0j plus 0k. Now for FAD equal to FD itself multiplied by, when we look at FAD, this one here, FAD is got 1 meter on the positive x-axis, 2 meters on the negative y-axis, 2 meters on the positive z-axis. Therefore, we have I, 1 meter on the I, minus 2 meters on the j, and plus 2 meters on the k. But since these are coordinates, we have to divide by the magnitude of this position vector in here. So the magnitude of this position vector, so finding this magnitude now, we have to take the square root, this magnitude here equal to the square root of 1 square plus negative 2 square plus 2 square. All of that will equal to 3 meters. So the magnitude in this case equal to 3 is equal to 3. So we have to divide by the magnitude. So equal to FD. So this is 1 over 3 I minus 2 over 3 J plus 2 over 3 K. And of course this one in Newton. Now if you simplify it further, this will be 0.333 FDI minus 0.667 FDJ plus 0.667 FDK. Again, it's in Newton. Now I represented all of these forces in a Cartesian form. Of course we have one more force which is straight downwards here on the z-axis, this force in here. You call it anything if you want to. This is E, for example, if you want to call it E or whatever. So DE, the force AE here, doesn't have any component on X and Y axis. It's got a component only on the negative Z axis. So just taking that into consideration. So now once we represent everything in a Cartesian form, now we have what we're going to do. So FAD, you can represent it or leave it because it's the same thing. FAE will equal to, we know it's 0I plus 0J plus it's 600 newtons on the K. It's let's put the 600 newtons here, or 600 on the K components, 600 newton on the K components. So this is all of the forces acting in there. So now we start to apply the equilibrium equation. So equations of equilibriums, sum of the forces on the x-axis should equal to 0. In this case we've got, starting with F for the FAB in this one in here. So what we have in here, FB, from here then we have FB on the x-axis plus FC on the x-axis plus FD on the x-axis plus FE on the x-axis, all should equal to 0. We know that we have here 0.5 sine 30, which is 0.5 for this one in here, 0.5 I or FB plus FC itself. In this case it's 1 for FC, it is 1, so FC minus FC, because FC it's negative 1. So what about FD? FD in this case again it is only 1, which is 0.33 FD, and again 0 for the FE. All of that should equal to 0. Simplify this, will be 0.5 FB minus FC plus 0.33 FD. All of this should equal to 0. Let's number this as equation number 1. Then we sum all the forces on the y-axis. Know that should equal to 0. So FB on the y-axis plus FC on the y-axis plus FD on the y-axis plus FE on the y-axis, all of them should equal to 0. Just plug in the values if they have any. So in this case for FBY we have 0.866 FB. For the FC it is 0, on the y-axis is 0, therefore it's here plus 0. For the FDY it's negative on the y-axis, which is 0.667 FD, and it is 0 for the FE on the y-axis. Simplify it a bit further, then 0.866 FB minus 0.667 FD should equal to 0. Let's number this as equation number 2. Sum of the forces, sum all the forces on the z-axis should equal to 0, and from here we can say that FB on the z-axis plus FC on the z-axis plus FD on the z-axis plus FE on the z-axis, all should equal to 0. We know that FB on the z-axis it's 0 K components plus FC again it's a 0 K component. FD is being given in there. This is for the FD 0.667 FD, and the FE plus the 600. Sorry, it's minus this FE, it's minus, it's straight downwards. This is negative 600 Newton. All of them should equal to 0. From here we can solve for the FD minus this one equal here 600 Newton. Then FD will equal to 600 Newton divided by 0.667. This will equal to roughly it's 899, so roughly 900 Newton. So it's roughly 900 Newton, and this is equation, let's number it as equation number 3. So we found FD and it is positive, so FD is in tension as we assumed it from beginning. So substitute 3 into 2. When you substitute 3 into 2, that we have 0.866 FB minus 0.677 multiplied by the 900 Newton, roughly we just found. This should equal to 0. Solving for FB from this case, FB equal to, multiply these two together will be 600 Newton. Then and you take it to the other side as well, then FB equal to 600 Newton divided by 0.866, and in this case will equal to 693, roughly 693 Newton, and let's call this is 4. So substitute then 3 and 4 into 1. When you substitute 3 into 1, so equation number 1, 0.5, which is the sine 30 times the 693 Newton minus FC plus 0.33 multiplied by 900 Newton. This all should equal to 0. From here we're solving for the FC. If we take that, solving for the FC in here will equal to, when you plug all of this in your calculator, should equal to 600 Newton. Again, it's positive. We already defined our sign conventions in the at the beginning, and these ones should be in tension again. See you guys in the next video.